Good morning, students. In this session, we'll discuss about the how to design a digital IIR filter from analog filter specification. So the two popular analog filters are Butterworth low pass filter and another one is Chebyshev filter. So for the given specification, first you should be able to draw the frequency response of the Butterworth low pass filter. So this is the frequency response of the Butterworth low pass filter. So the given specification, the ripples in the pass band, 0.9. This is the ideal characteristics of the low pass filter. So there is a ripples in the pass band, there is a ripples in the stop band. So the ripples in the pass band is given 0.9. So the ideal is 1 pass band, ripple is 0.9, and the frequency range from 0 to 0.2 pi, the omega. So 0.2 pi is the frequency range. Similarly, for ripples in the stop band is given in the specification 0.2. Okay, the frequency range from 0.4 to pi. So already we know the we derived the Butterworth low pass filter. So this cutoff frequency 1 by root 2, that is equal to 0.707 will give the cutoff frequency omega c, and this is a pass band edge frequency. This is a stop and edge frequency 0.4 pi, and the 1 by the ripples in the pass band square root of 1 plus epsilon squared 0.9, and the ripples in the stop band is divided by 1 by square root of 1 plus lambda square equal to 0.2. So from the given specification, first from the given specification, draw the frequency response and specify all the parameters. Okay, then the first one you have to determine the order of the filter. So what are the given specifications from passband edge frequency and stop band frequency? 0.2 pi and 0.4 pi. So what is the order of the filter? Either you can use n is equal to log of lambda by epsilon divided by log of 1 by k, or you can use n is equal to log of 0.1 alpha s minus 1 divided by 10 to the power 0.1 alpha p minus 1 divided by log of omega s by omega p. So by using either one of these formulas, we can determine the order of the filter. So if you want to determine the attenuation, the ripples in the passband, ripples in the stop band in dB, you can use this formula 20 log 10 of 0.9 and 20 log 10 of 0.2, which is equal to this is 0.91, 13.97. So if you are with respect to alpha p and alpha s, if you want to find out the order of the filter, you can use this formula. Otherwise, from this given data, directly you can determine the lambda and epsilon, and you can use this formula to determine the order of the filter. So from the given specification, the ripples in the pass band is given as 0.9. From this, the epsilon can be determined 0.483. Similarly, the ripples in the stop band is equal to 0.2. From that, the lambda can be determined 4.89. So by using this formula, n is equal to log of lambda by e 4.89 by 0.483 divided by log of omega s by omega p. So omega s by omega p. So here the omega s is 0.4 and omega p is 0.2. So 0.4 pi by 0.2 pi. So you can simplify and compute the values with the by using calculator, and you can verify the n is equal to 3.3. So n is approximately, you can take n is equal to 4. Okay, so if you use this formula, k is equal to omega p by omega s. Okay, this formula 1 by k. 1 by k means omega s by omega p. Okay, so once if we find out the order of the filter, then the cutoff frequency can be determined by omega p by epsilon 1 by 2 for Butterworth filter. So omega p is 0.2 pi and epsilon we determine, and the order is 4. So you compute the value of omega c. So you will get omega c equal to 0.7536. So this is the second step completed. Okay, once order of the filter is determined, then determine the omega c. Then next step, you write down the analog transfer function for the order is equal to n is equal to 4. So for n is equal to 4, from the table n is equal to 6, n is equal to 4, the polynomial coefficients you can determine from the table. So a naught plus you can write for the fourth order system, a naught plus a1s plus a2s square plus a3s cube plus a4 s power 4. So where a naught is equal to 1 for all n. So in the other coefficients, the partial coefficients a1, a2, a3, a4 can be determined from the table. So a1 is equal to 2.6, a2 3.4, a3 2.6, a4 is 1. So you can write the equation h of is equal to 1 by 1 plus 2.6 plus 3.4 square plus 2.6 s cube plus s power 4. Then you have to convert the frequency denormalization. So conversion of the normalized transfer function is a prototype low pass filter to uh, the prototype low pass filter to the low pass filter. So where put s is equal to s by omega c. Okay, so 1 plus 2.6 is equal to s by omega c substitute, and omega s c value you can substitute. Then h of s, you have to calculate h of z by using bilinear transformation, where substitute s equal to 2 by t, z minus 1 divided by z plus 1, or 2 by t, 1 minus z inverse by 1 plus z inverse. So you can substitute the omega c and s value and simplify and compute the values and determine the coefficients of the polynomial coefficients. You can determine the poles can be determined, and you can plot the poles also. Otherwise, you can determine the Butterworth poles by using this formula. When n is equal to r, you can determine the pi of k pi by n, or n is equal to even means you can use this formula k plus 1 by 2 of pi by n. So n is equal to 4, so up to 0 to 7 you can determine the poles positions. So poles position n is equal to 4, so pi 0 for k equal to 0, so n is equal to even, you can use this formula, you will get pi by 8. So the angle of the pole can be determined by pi by 8 is equal to 22.5. Similarly, you can determine the other poles pi 1, pi 2, pi 3, and for stability we have to consider only the poles between 90 and 270 degree. Okay, so this is a complete design, how to design for IIR filter from analog filter specification, Butterworth low pass filter using bilinear transformation. So the first step, first to plot the frequency response with the given specification, and what are the parameters are given, omega p, omega s, and ripples in the passband, ripples in the stopband. So from the given specification, we can able to determine the order of the filter by using either this formula or with respect to this formula. So if you want to use this formula, determine alpha s and alpha p. So in dB, you can determine 20 log of the given specification in the passband. So 0.9, similarly alpha s can be determined. So omega p and omega s passband edge frequency in the stopband edge frequency is given. So by using this one, the omega s and omega p, determine epsilon and lambda value, substitute and compute the value of order of the filter, so which is approximately 4. Once you find the n is equal to 4, you can determine the poles, and you can say determine the stability by using the kth pole and what is the angle of the kth pole. So and omega c can be determined by using this formula omega p by epsilon of 1 by n. So omega c can be determined. Then analog construction for n is equal to 4 can be determined, can be written from the table. N is equal to 6. The polynomial coefficients for a1, a2, a3, a4 from the table we can write. So a0 is 1 for all n. Then put once h of s, the analog transfer function is determined, then convert into z transformation h of z, where s is put for bilinear transformation, put s is equal to 2 by t z minus 1 divided by z plus 1, or you can substitute 2 by t 1 minus z inverse divided by 1 plus z inverse. Okay, then the omega c, the cutoff frequency, can be substituted. So either this way you can find out the h of z, or you can determine the poles and the stability of the system. You can determine by the kth pole. Okay, with this we can conclude the session. So hope that you understood the complete design flow of IIR filter design from the unlock filter by Butterworth low pass filter using bilinear transformation method. So the given to in order to find out the order of the filter, so the specification may be in different ways they may be given. So we can use either one of the formulas with the proper pass band edge frequency, stop band edge frequency, cutoff frequency, and pass band ripples and stop band ripples. So with that we can design a filter, IIR filter design. Finally, we can once if we find the coefficients coefficients of the feedback coefficients of IIR filter, we can realize the system in direct form 2. So either you can realize the system in direct form 2 or direct form 1. Okay, so with this we can conclude the session. We can take you can take so many problems from the exercise. You can refer the broadcast book or opening book or local author, the Nagarkani Indian author Nagarkani. You can refer for further practice.